In this video, we are going to look at section 6.3 and how to use proportions to solve problems involving similar polygons. So let's take a look at what similar polygons are. So anytime that two figures are similar, it means that they have corresponding angles that are congruent. Okay, so all your corresponding angles that are in the same spot from shape to shape, are congruent to each other. And then corresponding sides are proportional. So proportional means in the same ratio. So you're going to divide the two similar sides. So similar in one figure to the next. They're the same relative side. So if we take a look over here in these two figures, so they are similar. So we see that the angles are equal. So angle F. So if we highlight angle F here, this one's going to go with angle Z, both in the second position. So we can see that angle F is the same as angle Z. So they are equal to each other. Okay, because if the angles were not equal, then all of a sudden the shape would look different. Okay, it wouldn't have a corner, like a 90-degree angle here, obviously, if it changed the degree measure. So then for the sides are going to be proportional. Okay, so we're going to take the corresponding sides. So if I take GF goes with YZ. And I'm just going to put dots on it before we put tick marks, because tick marks mean that the two sides are congruent to each other. Well, we're working with a similar polygon now, okay? So you don't see the equal sign under here. It's only similar. So I'm just going to put dots just so that when I look, it's easier to identify. So then FJ goes with ZW. JH goes with WX, and then GH goes with YX. So that just makes it easier when you're like looking around, when you're just looking at the shape, to identify in case it's rotated or anything is weird. So we're going to take, I'm just going to put an A over here and a B over here. So when we're comparing these sides, we would want to take from the same shape. So I'm going to take from the A shape divided by the B shape, so 20 over 25. That should equal 16 over 20, which should equal 12 over 15, which should equal 24 over 30. So now a quick way to check this would be to just divide these in your calculator, and you would get a decimal, and you could easily check that all of these are the same. But if we're looking for the scale factor, we want that to be in reduced fraction form. So take a look at what would divide out of each of these. So these would each divide by 5. So then that would be 4 over 5. These would each divide by 4. So 16 divided by 4 is 4. 20 divided by 4 is 5. They're equal. This should happen the whole way. Divide by 3. Okay, so divided by 3 is 4. 15 divided by 3 is 5. Both of these divide by 6. And we'd get down to 4 to 5 again. So the scale factor of these is 4 to 5. Okay, so it depends on kind of how they ask you to write it, but 4 to 5. So scale factor 4 to 5. So let's take a look with perimeters. So if the scale factors, if the polygons are similar, then their ratios are also going to be equal to the ratio of sides, otherwise known as the scale factor. Okay, so we don't actually have to add them all up to figure out the ratio of the perimeters. So these two figures are similar, so let's just find any two corresponding sides. I like this 1 because I'm not going to have to simplify it. So I'm going to compare the 1 to its corresponding side, which is the 2. So the scale factor here is 1 to 2 from ratio of the sides. That means that the ratio of the perimeters is also 1 to 2. Okay, exact same ratio of perimeters, ratio of sides, both equal to the scale factor. Let's do a couple of problems here. So given that these two triangles are similar, now always go off of the similarity statement, okay, when you're trying to identify which sides go with what, because it could be rotated or flipped and you don't realize it. So let's put the dots on first. So RS goes with with XY. ST, the last two. Go with YZ, the last two there. Okay, and then that third set of sides would go together. So just so that we make sure, in case anything is weird. So identify all of the corresponding angles. So remember that corresponding angles are equal. So I'm going to take angle R and I'm going to say that's congruent to angle X, first and first. Okay, angle S is congruent to angle Y. They're both in the middle. And angle T is congruent to angle Z. They're both the last ones. Now that's the same as when the triangles are congruent. Now, when they're similar, then the sides are in the same scale, okay? They're smaller or bigger. So identify the three pair of corresponding sides and write their ratios. So we've already identified the corresponding sides up here, so now we just have to write them in ratio form. So we're going to take the 20 from this left shape compared to the 12 in the right shape. Okay, then 30 with 18 and 25 with 15. One other way I sometimes do it is just going least to greatest or greatest to least in one figure. So I'll take one of the shapes and just write the sides in order from smallest to biggest. Because when they're similar, the next one has to go in order from smallest to biggest to correspond with this. So then smallest to biggest to make sure you get all of the sides. So either way. So given that these two quadrilaterals are similar, what's the scale factor? So scale factor, you just have to have a ratio of any two corresponding sides. So let's take a look. I'm going to put a dot on AB and QR. Okay, both of those are filled in. So that's going to give me the scale factor. Now make sure that you look here and you go from ABC. So you take the number from ABCD first. Okay, dot, dot, the one from QRST that went together. Okay, any two filled in sides will work, any two corresponding sides. So these both divide by 6. So when I divide by 6, I get down to a scale factor of 2 to 1. So every side in this shape is going to be 2 times bigger than this shape. Okay, it's going to be double the size. That's what that 2 to 1 ratio means. So this one wants to know what is the scale factor of QRST to ABCD. So this one needs you to take something from the QRST shape first compared to ABCD. Well, we've already done it. Okay, we've already simplified it. That's why I wrote them in here. So now you can just flip it and do 1 to 2 as the scale factor. Then when it asks you to write a proportion to solve for X, so go up in the shape. I'm going to put 2 dots on the side that has the X. That's BC. So I want to figure out what side goes with BC. That's RS. Okay, so RS goes with that. So then I'm going to put a ratio here. Okay, do a proportion. X compares to 4, just like the scale factor. Okay, so we took X first, so we're going to take the 2 first, okay, over 1. So you can set it equal to the scale factor and solve. You can also do it to any other pair of corresponding sides. So we could have done it with the 12 to 6. You could have done it with 10 to 5, 16 to 8. Or just with your knowledge that this shape is 2 times bigger. So it's going to be 8. So you could have done it like that too. But then just, cross multiply here. So you get X equals 8 as your final answer. And this one would give you the same thing. You would get 6X equals 48. When you divide by 6, you'd get X equals 8. All right, last problem here. We've got 2 pentagons. We want to know the scale factor from the one on the left to the one on the right. So let's take a look. So when we're looking in this left shape over here, the only one that has a number is this side. So that's the one that I'm going to use to try to find a corresponding set. So FG better be filled in, otherwise I can't do this. Okay, and it is. So we want the number from ABCDE first, and then FGHJK second. Then reduce it. So both of these divide by 5. So 10 divided by 5 is 2. 15 divided by 5 is 3. And that's our scale factor. So then I like to just write it in the shape so that I remember. When I'm looking at this shape, it's all going to reduce to 2, and this shape's going to reduce to 3. So write and solve a proportion to solve for x. So here's the side that has x, that's AE. It's going to go with FK. So I'll set up a proportion. So x compares to 18, just like 2 compares to 3, because that's the scale factor. If you haven't found the scale factor yet, again, you can go x to 18 and then go 10 to 15. So if you haven't reduced the scale factor yet, because 10 over 15 is the same as 2/3. This one's just going to be already kind of reduced for you, so the math is going to be a little bit simpler. So just cross multiply, so you get 3x equals 18 times 2 is 36. Divide by 3, and you get x equals 12. All right, then we want to write and solve a proportion to find the perimeter. So remember, the perimeter of one shape compared to the perimeter of the other shape is going to equal the scale factor. Okay, so it's going to equal that scale factor ratio, which we already know is 2 to 3. So let's go ahead. We just need the perimeter of this second shape over here because it has all the sides filled in. So instead of having to go solve for each of these, we can just add these up. Okay, so what do we get? 10, 20, 30, 40, 50, 69 for that one. Okay, so the perimeter of that second shape is 69 units. We do not know the perimeter of the first one. I better not use x. We've already used x. So let's put p. So I do not know the perimeter of this left shape. I know the perimeter of the second shape is 69. And then that's going to simplify down to the scale factor, 2 to 3. So then I just need to cross multiply and divide. So we'll cross multiply here. We'll get 3p equals 138. Then we can divide by 3 to both sides. And what do we get? 46. So the perimeters will also simplify down to that scale factor.